Imagine setting up a direct line between two secret agents in different locations. In our JavaScript mission today, we're doing something similar with a digital tool called Broadcast Channel. In one script file, we open a channel named my_channel, like agent A picking up their spy phone. Meanwhile, in another script, agent B tunes into the same channel. With both agents connected, agent B sends out the first secret message, hello, from the other side. And agent A, with their ear to the digital ground, hears it loud and clear. Imagine you've got two friends who want to share secrets across a crowded room without anyone else listening in. They decide to use a special invisible channel that only they know about. Friend 1 whispers a secret into the channel, that's like using post message, to send a hello from context 1. Message. Now, friend 2, who's already tuned into the same invisible channel, hears the secret and smiles, acknowledging the message with a nod, or in this case, by logging received message, hello from context 1, to the console. It's a private conversation in a bustling space. Imagine you've got two tabs open in your web browser, or maybe you're working with background scripts called web workers. You want these guys to chat with each other, right? Well, let's set up something like a digital walkie-talkie. We create a new broadcast channel and give it a name, like example_channel. Next, we tell our script to listen for any messages coming through. When a message pops in, we grab it and do something cool, like updating the text on your web page to show the new message. Just like that, we've got crosstalk between scripts. So imagine you're working on something super complicated in one room and you want to share it with someone in another room without copying it all by hand. That's like using post message in web workers to share complex stuff like objects or arrays. The worker gets the message with all the details intact, thanks to this cool cloning technique. So instead of a messy scribble, the worker sees the exact same neat info you sent, just like this complex data with usernames and details showing up in the console. It's super efficient and error-free communication. Imagine you're tossing a ball that only you can see to a friend, but they miss it because it's invisible to them. That's kind of what happens when you send non-clonable data, like a function, through a broadcast channel. When your friend's broadcast channel tries to catch this invisible ball, it triggers an error event. They set up an on-message error event listener to catch and log the error. This way, they know what went wrong, although your message didn't come through. Imagine you're chatting with friends on an app, but one person heads out. They hang up to stop getting messages, kinda like the close method in broadcast channels. So when a broadcast channel gets closed, it's like telling the app, I am done chatting, no more messages please. Now, anyone still connected won't get new messages from the channel that's closed, just like others won't hear someone who's hung up. But we also need to make sure no memory's wasted holding on to the leftovers of our chat. That's why closing it properly matters. Imagine you're signed into a website and open it in another tab. Wouldn't it be great if both tabs knew your login status? With the Broadcast Channel API, they can. Here's how it works. When you log in on one tab, a message is sent on the user_login_status channel, alerting all other tabs. They receive this message and update to show you're logged in. And if you log out, the same thing happens, keeping all tabs in sync with your current status. It's like a group chat for your browser tabs. When creating channels with the Broadcast Channel API, it's super important to pick unique names. Let me show you why. Imagine one part of your code is listening for profile updates, while another part is waiting to hear about preference changes. If they both tune into a channel called user_updates, they can get their signals crossed. Suddenly, a profile update might trigger the wrong function, causing a preference update instead. It's like two people mistakenly picking up the same radio frequency. It's bound to create some confusion. Hey, did you know that the Broadcast Channel API is like an exclusive club? It only lets you chat with web pages that share the same origin. Imagine trying to join a party line from a different country code. It just won't work. So, if you try messaging across origins, you'll hit a wall, an error will pop up. But hey, if you want to whisper something to a page outside your club, you can sneak a note using window post message. It's like passing a secret message under the door, but, securely. Hey, ever tried sending a function through a broadcast channel? Spoiler. It won't work. Functions, files, blobs can't be cloned and sent over like other data. It's like trying to text a pizza to a friend. Technology's just not there yet. Check out this code where I tried to post a function, and yep, it crashed. Lesson learned. Stick to sending simple, serializable objects. Objects that play nice with JSON Stringify are your best bets for a smooth message passing experience.